In this video, we're going to learn how to solve problems involving simple harmonic motion for physics. We're going to practice with 8 repeated questions for this topic. Alright, so let's get started. The first question I have here says, the diagram shows 4 positions of the bulb of a simple pendulum. At which of these positions does the bulb have maximum kinetic energy and minimum potential energy? Alright, so guys, take note of this particular question. I have often seen it repeated. So for this particular question, the correct option will be option C, which is 2. The bulb will have maximum kinetic energy and minimum potential energy at the middle bulb. Okay, this middle one here, 2, and the lowest one. So that's it for this question. Let's go to the next repeated question. So this one says, in the diagram above, which of the simple pendula will resonate with P when set into oscillation? Also take note of this particular question. This diagram, I have often seen it as well repeated. So for this particular question, the simple pendulum that will resonate with P when set into motion, the correct option is option A, which is T, the pendulum T. The reason is that they have equal length and they resonate with the same frequency, pendulum T. So the correct option is option A, pendulum T. We have resonate with P. So that's it for this question. So let's go to the next repeated question. So the next one we have here says, which of the following affects the period of a simple pendulum? We have mass of the pendulum bulb, length of the pendulum, acceleration due to gravity. So the correct option in this question will be option C, length of the pendulum and acceleration due to gravity. These are features or characteristics that can affect the period of a simple pendulum. Alright, so the mass of a pendulum bulb will not affect the period of a simple pendulum. So these are parameters, length and acceleration. The correct option is option C. So take note of this question as well. Let's go to the next repeated question. It says, calculate the period of vibration of a spring system of force constant 200 Newton per meter when loaded with a mass of 2 kg. Alright, so for this question, we are going to solve this. It's actually very simple. We're going to apply this formula for finding the period of a simple harmonic motion. We're going to apply period T equals 2 pi square root of mass over spring constant. So in this question, we have the spring constant K to be 200 Newton per meter and we have the mass to be 2 kg. We are looking for the period, so it's going to give us 2 pi square root of 2 over 200. So when you cancel this, you are left with 2 pi square root of 1 over 100. This is the same thing as 1 over 100 is the same thing as 2 pi square root of 0.01. And square root of 0.01 is the same thing as 0.1. Okay, so it then punch. What we now do will be 2 times, remember our pi is 22 over 7, which is the same thing as 3.142 times 0.1. So let's bring a calculator and punch everything together and see what it's going to give us. So we have 2 times 3.142, okay, times 0.1. So we have the output to be 0.6284. So if we are approximating to 2 decimal places, it will be 0.63. So the correct option in this question is option D, 0.63. That will be the period of vibration of the spring system. Okay, so that's it for this question. Let's wipe this and solve the next repeated question. Alright, so the next repeated question we're going to solve will be this question. It says, if the length of a simple pendulum is half, its frequency is what? Now guys, before I respond this question, if you are new to our channel, ensure that you and subscribe to this channel for more of our videos. We really appreciate this. Alright, so looking at this question, also take note of this particular question. I have often seen it repeated. So for this question, the correct option will be option D. If the length of a simple pendulum is halved, its frequency will be increased by a factor of 2. Alright, so take note of this particular question. I have often seen it repeated. The correct option is its frequency will be increased by a factor of 2. Alright, so that's it for this question. Let's go to the next repeated question. So the next repeated question will be this question. It says, if the length of a simple pendulum is half, its frequency is 1. I think we have answered this question. In this particular one, the correct option is option A, increased by a factor of 2. The question used to get repeated often. Let's go to the next repeated one. So the next repeated question is this. The motion of a simple pendulum is what? So this question is very obvious, is oscillatory. Alright, so let's solve the last repeated question, and after you can call it a class. The correct option for this one is option B, oscillatory. So the last repeated question will be this question. It says the motion of a body is simple harmonic if the option A, acceleration is always directed towards a fixed point. B, acceleration is directed towards a fixed point and is proportional to its distance from the point. Acceleration is constant and directed towards a fixed point. Option D, path of motion is a straight line. Alright, so for this particular question, basically all you need is to know the right definition of a simple harmonic motion. You get it right. So for the definition of a simple harmonic motion being the periodic motion of a body in which its acceleration is directed towards a fixed point and is directly proportional to the displacement from the same fixed point. So for such definition, the correct option in this question will be option B, which is acceleration is directed towards the fixed point and is proportional to its distance from the point. So that's the correct option to this question, option B. Alright, so that's it for this video. These are repeated questions I have often seen under simple harmonic motion. Hope you learned something interesting from the video. Let's call it a video, guys. If you are new to our channel once more, ensure that you have subscribed to this channel for more of our videos. Also like, share and comment on this video to tell me how you feel from what you have learned from this video. If you seem to have any specific question to ask regarding what I've talked about in this video, feel free to leave your question at the comment section below and I will ensure to give you a response. Also ensure that you are part of our channel membership if you are not yet part of it. As a member of our channel, you will be receiving special information there that will guide you to excel in your exams. Alright, now click on the screen above and I will see you in the next video. Thanks for watching.